Now, second one is your interstitial solid solution. So first we have discussed, the substitution, or now second one is the interstitial solid solution. So I have, made you know about the point defects, and in point defects chapter we have discussed the vacancy, the interstitial, and the substitutional. Similar to that, here interstitial means what we have already made you. I mean, they are not replacing the atoms; they have in their own fashion. But whatever the space in between the atom is present, or you can say the void is present, that void is going to be filled by the other element. Now you can think about, if you have interstitial solid solution, what does it mean? Does it mean that, I mean, the foreign element atoms have the bigger size? No, because if the foreign elements have present, kept themselves in a order, and now there is some kind of the void. If void means, if that place, I mean, that void would be like obvious smaller than that element, because suppose if you have the ball of any radius size, okay, the Costco ball or whatever the ball, if you are keeping them together, then the void, the space that is being left, that must be less than of that parent your ball. Okay, so in that same sense, so you can think about, if the element which is going to be filled that you can think about them, the void is going to be filled by the atom or element which is always most less than the size. If we could talk about the size, that size must be less than of your parent element. Okay, but in case of the substitutional, you have the same size. Okay, because you are replacing the same area, same kind of places. So same places must have the same kind of occupation, right? So if they have replaced, means the atomic size of the foreign element or the solute element must be same of your solvent element. Okay, atom. Okay, but if you talk about in the interstitial solid solution, then the atom of the your solid element must be less than of your solvent element. So keep in mind, and you can, if you are you can think about, you can have idea with the diagram. Okay, so as you can see, this all the white one ball are, I mean, ball is kind of, which is basically here indicating the atom. Okay, so atom is like the circular. Okay, and in between them there's a void, and that void is being filled by the foreign element or the other other atoms, which must be less than. So as you can see here, okay, so you can think about how they are different from substitutional. So in substitutional, if you are going to ask what the kind of the element that can fill, that can replace in case of the substitutional solid solution, then you could think about, I mean, the element, the atom of the element which have the same atom radius, atomic radius. Okay, atomic radius define the basically the atom size. Okay, radius means, I mean, simple, just, I mean, if it's a circle, then it is what is the radius. So similar to that, as you know, from the school time, so similar to that, we have the atom. Okay, as I already told you in the first class, that what is the atom. Atom is at the center, there is a nucleus, and the electron is moving around this in an orbital form. Okay, so interstitial solid solutions normally have very limited solubility and are generally considered of the secondary importance. Why? I mean, as you can understand with this line, that interstitial solid solution normally have limited solubility. I mean, they cannot mix with each other, because they have a difficult task to come and fill this particular form, a void, okay, or the space which is left vacant or empty space. So that's why this is limited solubility. Solubility is difficult here. But in case of the substitutional, which is very easy, that's why it is very common. Okay, so consider, and in case, in some alloy, both interstitial and substitutional solid solutions are form of an appreciable extent. Means, I mean, some kind of a special kind of, or you can say, I mean, the limited alloy that we have, in which both are easily happen, or which it could be done in both the forms. But mostly, if we talk about the mostly, I mean, normally, generally, okay, we have not that much in case of interstitial Okay.